Hey guys, in this video, I will go through the process of checking main objects in a video. For example, checking boxer, but not the audiences in a boxing match. The aim is to check both the bounding box and the key points of the boxer in every single frame. We are going to use the YOLOv8 model for this task. There are a few problems that we need to overcome. The first problem is to detect the main objects, in particular the boxers, and skip unimportant objects, in particular the audiences. And the second problem is that due to occlusion, there might be frames on which the boxers are not detected. So we want to draw bounding boxes and key points even on those frames. While checking bounding box is already integrated in YOLOv8, checking key points is not. I will explore two methods to check the key points. So the first method here, I will use a linear transformation that map the old bounding box to the new bounding box to check the key points. And for the second method, it is not really a checking, but I will simply copy the key points from the last detection in case there is no detection at the current frame. Copy the key points from the last detection over the current frame. So now let's go through the code. Here we first load the YOLOv8 pose model. Here I use the M model, and we can print out the total number of parameters. Here there are 26 million parameters. In the first part here, I will need a few helper functions. The first helper function is to draw lines between key points, and the second one is to detect main objects in an image. That means large objects in an image. For drawing lines between the key point, first we need the list of key points of human body, which are nose, left eye, right eye, and so on. The connectivity between the key points will be indicated in this list, in which here we draw an edge between nose and eye, left eye 0, 1, or we draw an edge between nose and right eye, which is 0, 2, and so on. So here I have two dictionary, one for the key points, one dictionary for the key point and one list for the connectivity between the key points. So now I'm going to plot the key points together with their connection on an image, and I call this function plot key points. So here in this function, I pass in the argument image key points. We have the option to show. H here is a list of given H. We have an option to draw the labels on the key points, and we have option to save the image. So here in this function, most are default parameter except for key points. Key points here is a list of key point tensors in the form of x coordinate and y coordinates, and h was defined as before. So here we first make a copy of the original image so that we don't change it in the process. So we loop through all the key points, and here note that the key point here is a list of key points, and each list has 17 key points for human bodies. So this key point here is a list of 17 key points. We draw the edge between the key point, so we loop through the edge, which are connectivity between the key point, which I indicate here. For each of the edge, we first make sure that the edge indices are within the boundary of the key point array. So this is condition to make sure the edge indices are within the boundary. We extract the start point and the end point of the edge, and here we would like to handle the case where key points are padded with 0, 0. This is the case where the key points is not visible, and the model will pad key point with 0, 0. So in this case, we don't want to draw the line. So only when both of the start point and the end point are not 0, 0, we would draw a line between the key points. So here we simply draw a line using this command. After we draw all the lines, we will plot the key point themselves. So here we loop through the key points, and if the key point is not 0, 0, we will plot the key point. So here I use rect to draw the line, and I use a Y circle for key point. So in the case we have label for the key point, we also display the label. If we have the option to show the resulting image, then we can we can show it we can show the resulting image. And here I want to show using the same aspect ratio. So I would compute the ratios of the resulting image, the aspect ratio between height and width, and the figure size. I want to keep the width to 10, and the height will be scaled according to the aspect ratio, and then I will show the resulting image. If we have the save parameter to be true, then we can save a new file for the image on which we draw the key point and the lines between the key point. And here is a simple check. So I have an image in my local computer. I simply load it and run detection on the image using model.predict. And here, because I only have one image which is passed in model.predict, the detection here is a list with one element. So I extract the first element in the list, which is also the prediction for the image. And on this detection, I extract the key points, and the result here is the plot key point function that we just go through, and I put show option to be true. So let's run this. So here you can see I have image of Usain Bolt, and you can see all the key points are detected, and we have connectivity which are lines between the key point. So this function works well. That is the first helper function I need. The second helper function that I need is to detect the large objects in an image and skip unimportant object, which means small objects. So here this function have parameters image array, which is the original image in the form of an array. The ratio here is set to 1/5. That means whenever we have an object in which its height is bigger than 1/5 of the height of the frame, or its width is bigger than 1/5 of the width of the frame, we identify that object as a big object. The confidence score here is simply the score for the model to detect some object. First, we extract the height and the width of the image. We use the model to do detection on the image, and we extract the bounding box, the confidence score, the classification. The key points list here is the list of key points of the detections. So we want to return two lists. One is in the form of XYWH, confidence score classification, and the other list is the key points. So the result here is for the first list, and the key point list result here is for the second list that we want to return. We will loop through the bounding box, confidence classification, and key points. Whenever we have a bounding box in which the width of the box is bigger than the width of the original image times the ratio, or the height of the box is, this is height bigger than the height of the original image times the ratio, then we say that that is a big bounding box, and hence we have detected a main object. So we will append the result with the bounding box coordinates together with the score, classification, and for the key points we will append these key points, and we will return the result and return the key points. And the last function that I wrote here is the function that is used to prepare input to bychecker. I'm going to use bychecker in this video. So the input to bychecker must be a class instance with attribute of the bounding box in the form x, y, w, h, confidence score, and classification. So next, we are going to check the key points based on the bounding box movement, and we assume that the bounding box move linearly, which means the new coordinates of a bounding box is obtained by the old coordinates using a translation and a scaling. So imagine that we have two bounding boxes, one here and one here. We can always map this O1 to the new one by first translating the center of this O1 to the center of the new one, and then scale the x and the y directions so that we can match the two boxes. Using some simple mathematics, we can compute the translation vector and the scaling constants. And once we are able to compute, then for any point x, y in the O box, its new corresponding coordinates in the new box are as follows. So here I have written out the new coordinates of x, y in the new box. And the next function, in the next function, we will implement these equations. So in the function transform linear here, we want to update the key points based on the new and the old bounding box coordinates, which are given by the model. And note that we only want to transform the key points that are detected by the model, not the point 0, 0, which is padded by the model because it doesn't detect such a key point. So in this function transform linear, I have O boxes, new boxes, and key point list here is the list of key points in the O box. I want to return the coordinates of key points in the new box using this equation. So transform key point list will be the list that I use to get the new key points. We will loop through the boxes and the key points. So we make a for loop here, and key point transform here is the list of key points for a particular box. So note that in this function we have many boxes because in a single frame there can be many objects. And key point transform here store the 17 key points on a particular box. So here we extract the new key point together with old key points. Well, new key points and old key points from the box information here. The box here are assumed to be in XY format. We extract the width and the height of the O box, of the new box. Here I'm trying to write this equation in a nice way, that is in the matrix way. If you write in the matrix way, then x new, y new here is simply a vector. x1 prime, y1 prime here is also a vector. And the matrix that I want to form here is a diagonal matrix with scaling constant Rx and Ry, and then that matrix times x2 prime minus x1 prime, y2 prime minus y1 prime. So I want to write these two equations in a single matrix equation. So to do that, I need to have the width, which is x2 new minus x1 new, the height equal to y2 new minus y1 new. So x1 new, x2 new here are exactly x1 prime and x2 prime. So the measures here include the width and the height. The offset here I define to be the x1 new, y1 new, which is x1 prime, y1 prime in these equations. And then we simply loop through the key points in the O boxes. So key point in key points here mean key points in the O boxes. Whenever the key point is not 0, 0, then we compute the matrix for linear transformation of the new key points. So Rx, Ry come from the equation before, and the matrix here is a diagonal matrix with scaling constant x or y, and then we can do a single matrix equation to get new key point, and then we append it to the list, and we can get the final answers. Alright, so now we will put this into the context of by check and process the video that we have. So here we need to import namespace because to initiate by checker we need namespace. So here is a function to process the video. First we capture the video, extract the video features, width, height, FPS, number of frames. Here we print out some statistics of the video on the width, the height, and the number of frames. We also create a codec to write the output video. So here I have two dictionary, history and frame history. History is a dictionary where the key are the check ID. The values are bounding boxes, key points old, key points new. So for each check ID, we store the corresponding bounding box. The key points old, which means the old key point for that check ID, and the new key point for that check ID. It should be bounding box, because each check ID should correspond to only one bounding box. For the frame history, this is a dictionary which have values as which has keys as check ID and value as the frame number, which is the most recent frame in which check ID is detected. So why I need the most recent frame? Because in the case of occlusion, the model do not detect any bounding box, so I can refer to the last detected frame in order to draw the box on the object in which the model doesn't detect. So here are a few parameters. Buffer here is a maximum number of frames to retain the information in the case the model lose the detection. Min box here is the minimum number of boxes to draw in every frame, or the minimum number of objects that I want to detect on every frame. In my video, I know that there are 2 boxes, so now in any frame I want to draw at least 2 boxes for these 2 boxes. Last min result here is used to store the last result which detect at least 2 boxes. So whenever I have a result that has length only 1 or 0, I will refer to the last result that have length at least 2. In order to activate by checker, we need namespace. We need to pass in the parameter check high threshold, check low threshold, matching threshold, new checking threshold, check buffer, and view score. So in this parameter, check high and check low are used to control the matching between an old box and a new box that is given by the detection of the model. So whenever the score is bigger than the checking high threshold, which is bigger than 0.5, then we will directly associate the new detection with the existing bounding box. Whenever the score is between 0.1 and 0.5, we will do further processing in order to decide whether we should associate the new detection and the existing bounding box. Match thresh here is the parameter which is used to decide when we can identify the new detection with the existing bounding box. New checking threshold here is a score in which we use to initiate a new object whenever the score of a new detection is bigger than this number. In particular, I set this number to 0.6. Check buffer is quite clear, and view score is some parameter for fast computation. So to initiate by checker, we use by checker passing in the arguments and passing in the FPS of the video, original video. So here is the process. We go loop through the frames. So here I will use frame index instead of the usual way where we put the while loop equal to true and we continually read the frame until we break out of the true while loop. However, in this video there is a problem of failing to read the last few frames. So if I do the usual way, then I will not be able to write the result into a new video. So I will use frame counter here. So I will read every frame, and here I have return and frame equal to cap.read. If I don't have a return value, that means I fail to read some particular frame. I will skip that frame and continue to the next frame. In the case the read is successful, I will first perform prediction on large objects using YOLOv8. So here I will refer to the detect large key points function that I wrote before, and this function gives me the result and the key points. The result here contains the information about the bounding box, the confidence score, and the classification of the bounding box. So if in the result I have less than 2 box, min box here is actually 2. If I have less than 2, then I will refer to the last result which I have at least 2 box. If not, then I will update the last result to be the current result. And here I will prepare input for by checker by extracting out the bounding box, the confidence, and the classification from result. And now checker input will be a class instance with bounding box in the form XYWH, confidence score, and classification. In order to check the current frame, we simply call checker.update on the inputs. So check frame here is a list that consists of 8 components that I already write out. The first 4 are bounding box in the format XY, top left and bottom right. The next one is the ID of the check, and then we have score, class, and the index. For the old bounding box, I will convert it to the XY format because if you notice, when I extract out the bounding box, it is in the XYWH format. So here the O box, we will O box here is a list of box. So for each box in this list, we will convert it to the XY format using this simple conversion. So XYWH is the format where XY is the center of the box, W and H are width and height of the box, and here is a conversion to XY, which is a top left, bottom right format. Now we will extract from the check result, which is the check frame here, the IDs and the new boxes for plotting later. So the IDs here is at the 5th coordinate, so it is check frame at the 5th coordinate. The new boxes are at the first 4 coordinates. Now we will get new key points on the new boxes, because here we want to have the new key points that follow the same motion as the new box, which is translation plus scaling. So I would use the function transform linear that I write earlier. In this function, I need to put in the O box, new box, both in XY format, and the O key points, which are key points in the O box. And this function will give me new key points. And once I get the new key point, I will update the history with the current check ID and bounding box. So I will loop through the check ID, bounding box, and new key points. Then the history at check ID will be a list of bounding box and new key points. Then the frame history of check ID will be the current frame in which check ID is detected. I also need to remove the check IDs and bounding box that were not seen in the last 30 frames. So I loop through all the check ID in history, If the check ID doesn't appear in the last 30 frames, then we delete that check ID from both history and the frame history. The last few lines will be used to plot the new bounding box together with the new key points. So we loop through history, we have bounding box and key points. So here first we will draw the lines and the key points on the frame. So we use the function plot key points that we wrote before, and we will draw bounding box and check ID using the box coordinates, and we write the frame and increment the frame by 1 for the next process. Let's run this and let's see the result. Well, a few words here that while we try to use a reasonable way, a way that makes sense to check the key points, but that might not necessarily be optimal. What we have done is we check the key points based on the movement between the old box and the new box, which we assume to be translation and scaling. First issue, that might not always be the case. We don't know what type of movement that is between the old box and the new box. And the second more important issue will be, in this way we are ignoring the relative position between the key points, and we only care about how the box move, and in that way that will create a serious problem because we need to take care of how the key points move in relative to other key points, not in relative only to the box that contain them. And here I already get the output. I guess this is the one. Well, as you can see here, I've set the ratio to 1/5, which is not so good, because for these 1/5, the height of these people probably is more than 1/5 of the height of the frame. So that's why the model even draw out these people here. I should have set the function plot large objects. I should have set the ratio to be smaller. So here plot key points, detect large. I should have set maybe ratio to 1/3 or 1/4. I think 1/4 will be reasonable. Alright, while it is running, so next I want to simply copy the key points that last appear to the current frame. So basically we do not have any checking effect in the next code, and we want to compare between the two methods. So for this method, we will look at the result later. Let's go through this method first. For this method, we basically copy the key point. So we also read the video frame, extract out the features, create a codec to write the output. We also maintain two history, one for the check ID and the corresponding bounding box together with the key points. Should be key point O because we are not going to check. One is for check ID with the frame number that is the most recent frame in which check ID is detected. We also have the setup exactly as before. Here we loop through the frame and we do prediction on large objects using the function that we write before. We extract out the result about the bounding box, confidence score, and classifications. We form the input for by checker, and then we use by checker to check the input. After the checking, we extract the result, that is the IDs of the checking and the new bounding box coordinates. And here we will update the history with the new result, and we remove the IDs and the bounding box that were not seen in the last 30 frames. For the plotting, we only use the key points, which are the ones detected by the model to plot. So we look through the history. We will plot the key points. So here you can see there is no new key point. We just use exactly the key point detected by the model, and then we draw the bounding box together with the check ID. Let's run this also. So here, while this is running, let's open this video. So here you can see there is a very snappy effect which we see in this video, which is caused by the attempt to check the key point using only the movement of the boxes. So by using only the movement of the boxes, we ignore the movement among the key points themselves. That is even more important, right? And that is not good, and it will create something weird like this, some snappy effect, because it basically ignore about the relation between the key points themselves. So you can see the human pose is not preserved because we do not take into account of the relative movement between the key points. Now we should finish with the other way, where we simply copy the key point that was detected by the model. Now in this way you can see the result seems much better. There is no snapping effect where the key point just suddenly snapped like to this side or to the side that has no relation to other key points. The reason is because we simply take the key point that are detected by the model, but one downside here is that there is flicking among the frame because we have no checking effect between the key points. So by the way, here I should have set the ratio just now 1/4 to smaller, because this person is still detected at the end. Alright, so now well, as the conclusion for this video, we will put a small code to put these two videos side by side so that we can compare them. So here I simply use movie py, and I import video file clip and clips array. I extract the two video files, resize so that they have the same height, and then combine them side by side and export on the final video. Alright, so this is the answers side by side video. Yeah, this the right one is the one that we try to check using the linear movement between the two boxes, and the left one is the one we simply copy the result by YOLOv8. In conclusion, in this video, I have tried to check key points between video frames. However, the result is not successful. I've worked on this problem for a few days, and I realized that now it is to the point that I realized that it was actually solved in the literature. There's a model called AlphaPose, and AlphaPose is able to check key points. In the future, I might make a video about AlphaPose. This is the end of my video. See you next time.